All right, so we're looking at A cross B. So from the determinant method, we have this kind of standard definition we use. So we make this 3 determinant out of it. Always the top row is ijk. Then we put in the elements of the first vector into our second row. So just the coefficients in front of ijk. So I'm going to copy the 4, the 3, the positive 12, and the units of A outside, just to remind us. And then the third row is the entries of the second vector in the cross product. So just the coefficients in front of that. So for B, it's negative 2, 5, negative 14, and that's in meters. Right, so this is the basic setup to do the cross product, making this 3 by 3 determinant. So the next thing we do is we make our cofactors in order to expand this out. So we're going to have a cofactor in front of an I term minus a cofactor in front of a j term plus a cofactor in front of a k term. So again, the method we use to find out what's the stuff we put inside these is for I, we cover up the I column and the I row and copy everything that's left. So we cover up the I, we're left with the 3, the 12, the 5, and the negative 14. We cover up the j column and the j row. We're left with the 4, the 12, the negative 2, and the negative 14. And then for the k cofactor, we cover up its column. We're left with the 4, the 3, negative 2, and the 5. We now have the 3 cofactors. We can now expand them using the definition that we had on the previous slide. So it's the product of the main diagonal minus the product of the off diagonal. So for the I, I'll use kind of extra brackets here to make it a little bit easier to look at. 3 times negative 14. This dot is a multiplication sign. Minus 12 times 5. All of that times I hat. Minus, same thing for j hat, so 4 times negative 14 minus 12 times negative 2 times j hat plus 4 times 5 minus 3 times negative 2 k hat. So like I said before, you have to be very careful here on the making sure like the order of operations is right, because we have a negative here, we subtract a quantity. Like in this one, we're subtracting what's going to be a negative quantity, so this will become positive. So just be careful when you're putting into your calculator that you're getting the right signs on things. So then the last step is just doing all these operations and getting our final result. So we get our coefficient in front of I is going to be negative 102I. In front of j, we're going to be left with a positive 32j. And in front of k, we will be left with a, where am I here? 26k. This is a vector, again, it has ijk components, and it also will have units associated with it, which is the product of the units of the 2 vectors that we crossed. So this is in Newton meters. All right, questions on any step to find the cross product between these 2 vectors? All right, so same operation every time. Make the 3 by 3, get the cofactors, expand them out, and then you get your final result. So in part 2, we want to find n hat, which again is the direction normal to the plane that AB lie in. So how do we find n hat? Right, so this thing tells us a vector that lies perpendicular to that plane. So this, we specifically want the unit vector that's perpendicular to the plane. So right, we can take what we just found, normalize it, and that will give us just the direction, or a unit vector, in the direction of this, but with magnitude 1. So n hat we can find by taking A cross B, divide by magnitude A cross B. So A cross B we just found in the previous step. So I'll write that down exactly the same. So we want to find the magnitude of this, just like we did before. So it's the square root of the sum of the squares. So the square root of 102 squared plus 32 squared plus 26 squared does, in this case, come out to be a nice number. It comes out to 110, is the magnitude of A cross B. So now each term we can divide by that magnitude. I did this one as a decimal. So negative 0.927i plus 0.291j plus 0.236k. It's a unit vector. There are no units with it. This was in Newton meters. This was in Newton meters. This is a unitless quantity. So again, if we wanted to double check, if we take the square root of the sum of these squares, we better get 1. Because we're saying it's a unit vector, we put that hat over the end. All right, questions on part 2? All right, so last step, this is actually the easiest one at this point. What's B cross A? Yeah.
102i minus 32k minus 26.
Right, so even more generically, before we get to that, from the previous slide, the order we do this in matters. That's going to be negative A cross B. So exactly like you said, we just have to negate every element of the previous answer, or of 2 previous answers, and this will also be in Newton meters.